Munich, Germany, 1884. A boy lies sick under heavy wool blankets. The window is frosted. Silence fills the room until the door creaks open. His father, Hermann, steps in. No words, just a small brass object placed in Albert's tiny hand. A compass. The needle twitches. Albert watches, transfixed. It moves, but no one touched it. It moves even when he does nothing. He turns it, tilts it, shakes it. Still, it points north. Something is guiding it, something invisible, something real. Later in life, he would recall this moment as his first brush with wonder. Something deeply hidden must be behind things. He is not a prodigy in the usual sense. He is slow to speak. Teachers say he's lazy, dull. But inside, a storm brews. He builds card towers alone, 14 stories high. Not for fun, for mastery, for stillness. He plays violin. His mother, Pauline, insists. He resists at first, then surrenders to the emotion, especially Mozart. His mind sharpens note by note. And in school, he suffers. Strict Prussian classrooms, barked orders, memorization. One teacher tells him, "Einstein, you will never amount to anything." Albert smiles slightly, because the compass still spins.
At 15, Albert has had enough. He walks out of school, literally. Without permission, he leaves Germany and rejoins his family in Italy. There, free from formal schooling, his mind expands. He devours Euclid's Elements. He calls it the holy geometry book. Logical, clean, infinite. It gives structure to his thoughts, truths that don't rely on authority. He studies Kant, Spinoza. Philosophy becomes a tool, not a distraction. He begins to shape his own framework of reality. But he needs a diploma. He applies to the Swiss Federal Polytechnic School in Zurich. Fails the entrance exam. Math and physics, outstanding. French and botany, disaster. But the director sees potential, allows him to enroll after finishing secondary school. In Zurich, he finds freedom and Mileva Maric, a brilliant Serbian physicist in training, the only woman in his class. She is sharp, serious, logical. They fall in love over equations, over debates about Newton, over shared rebellion against authority. Albert writes strange things in his notebooks. If I could chase a beam of light at the speed of light, what would I see? The question haunts him. Would the wave freeze? Would time stop? He has no answer. Not yet.
Despite his brilliance, Albert's grades suffer. Professors don't like his attitude. He skips lectures, questions assumptions, refuses rote thinking. When he graduates, no one offers him a job. He sends letter after letter. Nothing. He tutors children, lives hand to mouth. Then, finally, a position opens. Technical expert third class at the Swiss Patent Office in Bern. It's a dull job, reviewing inventions, checking diagrams, making sure machines work on paper. But for Albert, it's perfect. From 8 to 5, bureaucratic stability. From 5 to midnight, pure thought. He begins writing papers, discussing ideas with his friend Michel et Basson in cafes, scribbling thoughts on napkins, margins, and receipts. At night, he debates with Mileva, She types his drafts, challenges him, inspires him, and the beam of light still chases him. One evening, watching synchronized train clocks across Bern, he wonders, what if time is not absolute? What if simultaneity depends on the observer? He doesn't know it yet, but he's about to change the world.
Albert's office is modest. A desk, a window, stacks of applications. He examines blueprints for mechanical gadgets, egg cookers, gearboxes, synchronized clocks. He's methodical, efficient, but never fully present. What he loves is thinking, walking to work with a notepad in his pocket, stopping to scribble at fountains, bridges, train platforms. His mind is a workshop. In 1905, in his spare time, he writes and submits 4 papers to Unveiled der Physik. Each one alone would be enough to make a career. Together, they reshape physics. Photoelectric effect. Light can act as particles, photons. This explains why light can eject electrons from metal. A step toward quantum mechanics. Browning in motion explains the jittery bands of particles in water, proves that atoms exist, still debated at the time. Special relativity, a bold theory. The speed of light is constant for all observers. Time and space are not fixed. They bend, stretch, and contract. E equals MC². Mass and energy are interchangeable. A universe-altering insight hidden in a small equation. At first, the world ignores him. Who is this Einstein? Just a clerk? But Max Planck, father of quantum theory, takes notice. He champions the young outsider. Invitations follow, speaking gigs, professorships. The man who changed physics without a lab, without a title. All from a desk.
In 1907, Einstein sits in his office chair and has a revelation. A man in free fall doesn't feel his weight. He calls it the equivalence principle. Gravity and acceleration are indistinguishable. This simple thought will guide him for the next 8 years. But he is stuck. Newton's gravity doesn't explain how it works, only that it works. He wants the why. He needs new tools. Geometry beyond Euclid. Enter Marcel Grossman. Grossman, a mathematician and old classmate, introduces Einstein to Riemannian geometry, a powerful way to describe curved space. But the math is brutal. Tensor calculus, geodesics, curved manifolds. Einstein struggles. Pages of calculations, errors, dead ends. He is now a professor in Berlin. Famous, yes, but increasingly isolated. His marriage to Mileva is collapsing. Letters grow cold. Their partnership breaks. He begins an affair with his cousin, Elsa. He continues his work obsessed. Gravity, he believes, is not a force. It is geometry. Math bends space-time, and objects move along that curve. He's close, but not finished. 1914. Europe erupts into war. Einstein is one of the few German academics to oppose the nationalism sweeping the country. He signs no war pledges, refuses patriotic declarations. He lives alone, eats little, survives on boiled potatoes and turnips. But in his tiny Berlin apartment, he works obsessively. He is no longer alone in chasing gravity. Mathematician David Hilbert in Göttingen is racing him. They exchange ideas, then begin to diverge. Hilbert develops his own version of the field equations. For a moment, it seems he might publish first. But on November 25, 1915, Einstein presents his final equations to the Prussian Academy. 10 elegant symbols. A masterpiece. He writes to a friend, "Hardly anyone has taken as much trouble in the world with the subject of general relativity as I have." He has done it. He has rewritten gravity. 1919, a solar eclipse is coming, a chance to test Einstein's theory. If he's right, the sun's gravity will bend light from distant stars. British astronomer Arthur Eddington organizes an expedition to the island of Principe. Despite war tensions, science reaches across borders. May 29th, the eclipse arrives. Photographic plates are developed. The light bends, just as Einstein predicted. The London Times declares, "Revolution in science. Newton overthrown." Einstein becomes a global icon, not just a scientist, a symbol of genius. Newspapers print his face. Crowds gather at lectures. Children write him letters. But Einstein grows wary. Fame distracts, distorts. He says, "The cult of individuals is always, in my view, unjustified." Still, the world watcheth. The clerk from Bern has bent the cosmos.
In 1921, Einstein wins the Nobel Prize, but not for relativity, for his explanation of the photoelectric effect, a safe choice. By now, physics is shifting again. A new field emerges, quantum mechanics. It challenges causality, predictability. At the 1927 Solvay conference, Einstein faces Niels Bohr. They argue day and night over wine, over chalkboards. Bohr believes the universe is fundamentally uncertain. Einstein counters. God does not play dice with the universe. He refuses to accept randomness at the core of reality. In 1935, he and two colleagues published the EPR paradox, arguing that quantum theory is incomplete. They describe spooky action at a distance, instant connections across space. At the time, it's dismissed. Decades later, it becomes the foundation for quantum entanglement. Einstein, once again, is ahead and alone.
1933. Germany is falling into darkness. The Nazis rise to power. They burn books, including Einstein's. He is labeled a traitor, a target. He flees, first to Belgium, then to England, finally to the United States. He accepts a position at the Institute for Advanced Study in Princeton. Safe, but haunted. He learns of Jewish scientists trapped in Europe. He writes over 500 letters to help them escape, uses his fame as leverage. In 1939, he receives a warning.
physicist Leo Szilard tells him Germany may be building an atomic bomb. Einstein reluctantly signs a letter to President Roosevelt urging the U.S. to act. It becomes the spark for the Manhattan Project. But Einstein is never invited to join. The FBI deems him a security risk. Still, his equation E equals MC² powers the core idea. August 6, 1945, Hiroshima. Einstein hears the news. He whispers, "Whoa, it's me." Later he says, "Had I known, I would have become a watchmaker."
Princeton, New Jersey. Einstein finds quiet in this small university town. He walks to work, plays his violin, chats with school children. But one companion intrigues him more than any other: Kurt Gödel, a brilliant logician, fragile, reclusive, but sharp. They walk together every day, discuss the limits of knowledge, time travel, infinity. Gödel shows Einstein a strange solution in his own field equations, one that allows for closed time loops, time travel in theory. Einstein listens, smiles, but he's weary. The world has changed. He's become a symbol more than a scientist. Younger physicists, Feynman, Gell-Mann, dismiss his unified field work, say he's chasing ghosts. But he keeps working, day after day, trying to unite gravity and electromagnetism, to see the universe whole. For 30 years, he searches. He ignores the nuclear forces, a mistake. Yet he never stops. In 1955, he suffers an aortic aneurysm. Doctors recommend surgery. He refuses. "It is tasteless to prolong life artificially. I have done my share." He asks for pencil and paper, scribbles a final line of symbols. They're lost. A nurse cleans the tray. His last words, spoken in German. The American nurse doesn't understand.
After death, his brain is stolen. Literally. Pathologist Thomas Harvey removes it during the autopsy, keeps it in a jar, later slices it into sections, sends them to researchers. Some claim to find anomalies, others call it myth, but the story sticks. Einstein's mistakes echo louder than most people's successes. His EPR paradox, once ignored, becomes the basis for quantum entanglement and quantum computing. His so-called blunder, the cosmological constant, now explains dark energy, which drives the expansion of the universe. His 1916 prediction of gravitational waves is confirmed a century later by LIGO in 2015. Even his 1926 refrigeration patent, made to help poor families without electricity, is now used in solar-powered vaccine coolers in remote regions. Einstein transcends physics. He becomes an icon of curiosity itself. But he was never comfortable with the image. He said, "I have her special talents. I'm only passionately curious."
So, why does he matter? Why tell this story? Because Albert Einstein was not a superhuman. He was messy. He was wrong, often. He failed his first entrance exam, was rejected by professors, denied jobs, laughed at. He made enemies, ignored people, let relationships crumble. But he had one thing: a compass, a deep, unshakable pull toward something hidden, a mystery that made him sit up in bed, walk along through snow, scribble by candlelight, defy nations, defy war, defy the very structure of space and time. That compass lives in all of us. Find your compass. Break one rule. Fail gloriously. The universe isn't finished. Grab a piece of chalk. Bend space-time. Genius isn't a superpower. It's a stubborn child with a compass, asking why, long after the world says enough. Albert.